So to remind ourselves with the baseline scores for the three models that we have, let's recall the variable that we have stored our baselines, and then we just can call it, and then we can talk about how we so our baseline model for the logistic regression random forest classifier, the KNN model. So the logistic regression here, let me take the model scores which we store our scores at. If you recall that we tried to do hyperparameter by hand using the KNN model, and we haven't seen any improvement. We call this as baseline models scores. We run this, and then we'll talk about how each of the model has been tested to be improved or not. So our logistic regression was doing quite good, around 88 to 89%. The KNN model, even though we try to model tune it, however, we haven't seen a better results. And the random forest, we tried tuning it using the random forest classifier model. You could see that there is quite improvement compared to the KNN model, which we have here. We haven't seen a quite better performance. So next, let's again try a new thing called the hyperparameter tuning with a method called GridSearchCV. To perform the hyperparameter tuning using the GridSearchCV, we'll start first by trying this method on the logistic regression again. We'll need to specify the hyperparameters like the param grid to explore the various combination of hyperparameters. So what exactly GridSearchCV method will do compared to the random forest classifier method? So the random forest classifier, it enables you to try different hyperparameters, and then it tells you what are the best uh, parameters compared to the GridSearchCV. So the GridSearchCV method will search over the grid and find the best combination based on the cross-validation performance. So the steps we are going to take, first we'll define the hyperparameter for the logistic regression as I mentioned. So we'll now start tuning again the logistic regression to see whether the grid search CV method could return to us the best hyperparameters as we have done here. If you recall that this is for the random forest, it has returned it for the best parameter for the random forest classifier model using the RandomizedSearchCV. So these were the best parameter for the random forest classifier model. And then we have our logistic regression using the RandomizedSearchCV. It has returned these hyperparameters to us. And as I mentioned, also for the KNN model, it hasn't done so far compared to the baselines that we have. So let's move now on and again discuss about how GridSearchCV could help us. So first, it will help us by defining the hyperparameters, the best hyperparameters for the logistic regression. We'll tune the hyperparameters like the C, penalty, and solver. that we have seen before. So to remind ourselves what is C, what is penalty, and what is solver. So C is the regularization strength. Smaller value indicates stronger, regularization. We have also the hyperparameter called penalty, which is a type of regularization. To use, there are some values like 11, 12, or none. Also, the last hyperparameter for the logistic regression that we are gonna use, solver. So solver is an algorithm used for optimization. Some solvers supports only certain penalties, like the linear, which has some limitation to use the penalty values 11 and 12. So to use the GridSearchCV to find the best hyperparameters, we're gonna use also some functions to help us evaluate the performance of each combination of the hyperparameter using cross-validation. Since our logistic regression model provide the best score as a baseline, we'll try to improve them using the GridSearchCV. To start with that, let's start typing the code. Let me just add some text here to remind ourselves that now we are gonna try the GridSearchCV. Search CV for the logistic regression model. Typo. Let's bold this one. And also let me call this one as 8.4 since it's under the hyperparameters tuning using the GridSearchCV for the logistic model. Let me call it hyper. Let me do this also as bold. Now we're good to go with the start, building the code. Make your text bold. I'm gonna use the to start with that. Let's set some different hyperparameters for our logistic regression model. You just comment that. Regression model. So we'll set some different, hyperparameters, and we'll enable the GridSearchCV to search through all of these hyperparameters and find the best one and return it to us. So to do that, we'll start by setting the log grid is equal to, and then we'll set the C value, if you remember, for the regularization. Then we'll set that into the dot log space. Set that to go through S4, also 4, and then 30. Then we'll set the solver value equal to a linear. So we said our solver value has to equal to linear. So now we're done from setting different hyperparameters for our logistic regression. Let's now set up the grid hyperparameter search. So, to be able to use the GridSearchCV function to go through the logistic regression and find the best parameters. Let me type there, set up the grid hyperparameters. Search for the regression model. To do that, we'll set the log equal to GridSearchCV. Then we'll use our logistic regression model. Now let's set the from grid search. Okay, from grid is equal to grid Where's validation need to equal to 5 again. This need to put true. Let's close that now. Now let's fit our grid hyperparameters to the search model. Fit grid search model on the training data, and then we'll test its results on the testing data. dot fit. We'll use our training data sets. Don't worry, I'm gonna again explain and go through each of these so you can understand them. Maybe you need, to add comments next to them so you can understand why we have reached or used these hyperparameters. Let me, okay, this might take some time because it's gonna fit the model and find the hyperparameters using the GridSearchCV. So here on the C value, if you recall that we say that the C is equal to the regularization, we have set it into the log space -4, 4, and 30 to generate a series of values for the regularization parameter C. And ranging from the 10 times by -4 to 10 minus 4, this will allow the model to explore a broad range of regularization strength. And in our case, we use the solver to equal to liblinear. We have restricted it to which supports both L1 and L2 penalties. On our GridSearchCV, we use the logistic regression, which we are trying to tune now and find the best parameters. We use the cross-validation equal to 5, which means the data will be again split into 5 parts, and the model will be trained and evaluated on each part once. And for the verbose, we set it to true, and this will show a detailed logs about how the grid search process goes, so you can track the process. It was shown down below, if you recall them. And yeah, the param grid is set to log the grid, the grid of the hyperparameters to search over, which in this case only includes CN and solver. And then we use the fitting function. So this will perform the grid search and fits the model to each combination of the hyperparameters. So after we run the code, as you could see that the GridSearchCV has went through all of these hyperparameters, and let's see now. So our logistic regression using the GridSearchCV, it has found the best C value is equal to 0.20, and the solver again is equal to the liblinear. So this is how we fit our model to use the GridSearchCV, which we applied to the logistic regression model. And we use our GridSearchCV to search the best hyperparameters and to evaluate the performance for each combination of the